Yes, means sound waves, right? Hi guys. So sound waves. So before going ahead with just just so before understanding how to find the velocity of a sound waves in air medium, what is the velocity of sound in air medium? Just let us try to have an idea about uh, a few characteristics of sound waves. Characteristics of sound waves. Characteristics of sound waves. Right. One of just a second. Okay, fine. You see, um, so first we'll see. First one is loudness. Loudness. Actually speaking, it is determined by, or you can say, it is the sensation of hearing. How loudly you will hear the sound is called loudness, but it is somewhat related with the intensity of sound, and an intensity of sound in turn relates with amplitude of sound. So you can say that the sensation of receiving by ear due to intensity of sound is called loudness. What is that? The sensation of hearing. Yes, the sensation of hearing. Right. You can say that uh, due to due to intensity is called is called due to intensity is called loudness. Okay, so that sensation of receiving the sound by ears is called loudness. Okay, and as the intensity is, I already we know that intensity is directly proportional to amplitude square. How we have arrived at this expression? How we have arrived at this expression? Already we have discussed that intensity is defined as energy, sound energy, uh, per unit surface area per unit time. Sound energy falling for a given area in unit time is called intensity. And this is nothing but energy. Sound is a form of energy. You can say energy means energy of sound. Sound energy per unit time is called power. You can also express this as average. AVG means average power by area. So this we have derived this expression as is equal to 2 pi square f square and a square rho into v. Here f is frequency of the sound waves, a is amplitude of sound waves, rho is density of the medium in which the sound waves are traveling, v is velocity of the sound waves. So if frequency, density and velocity are constant, from this you can say that intensity of sound is directly proportional to amplitude square. Not only sound wave intensity, any wave usually will say if other parameters remains constant, intensity of any wave is directly proportional to square of the amplitude. Whether it is a light wave, for light waves also we will apply the same condition. How we have arrived at this is based on this relation. We arrive that intensity is directly proportional to square of the amplitude. Right. Next, simply you have to just remember that another characteristic of these sound waves is sound level. Sound level, loudness, and another one is sound level. The sound level means, again, this is also kind of as a loudness is the sensation of hearing due to the intensity change or intensity. You can say this is the usually, so you say the loudness in somehow you can call it as how large is the intensity and or how big is the loudness that can be measured with the help of another parameter called sound level. This it will try to express this in terms of a different parameter called sound level, and we use a unit to measure the sound level, which is called as decibel. You can say the unit of sound level unit of sound level is decibel. It is denoted by small d capital B. This is decibel symbol, right? And sound level usually will be represented with the different parameters beta. So if beta is sound level and it can be measured with the help of a mathematical expression. Okay, right now we are not discussing how to derive this. Okay, 10 log of I by I naught, where I is the intensity of the sound. So directly intensity, you are not considering the intensity is sound level. Log of intensity is giving somehow sound level, that is denoted by beta. So, for example, if a sound is having a sound level of intensity I1, if a sound is having an intensity I1, its sound level is given as beta 1 equal to 10 log I1 by I0, where I0 is the reference intensity, and another sound is having a different intensity, and hence its sound level will be different. It is denoted by 10 log of I2 by I0 is said to be another sound is which is having a different intensity will be said to be having a different sound level. So we can express it as beta 2 equal to 10 log I2 by I1. Okay, this difference between these two sound levels is denoted by beta 2 minus beta 1 is equal to 10 is common. If you take it as log beta 2 means log I2 minus by I 0 minus log I1 by I 0. So if you write it as log, it is in the form of log A minus B, so it is log A by B, I2 by I 0 by I1 by I 0, I 0 and cancel, so we'll get log of I2, we'll get it as log I2 by I2 by I1. This gives a short expression for difference between sound levels of any two sounds with respect to reference I0. Right? So, so this is briefly. Now we are not going to the details of measurement of sound levels. Is raining. Now, Just let us get into there are so many different some other different parameters are there which characterizes the sound. We are going into those things now. Let us take discuss about the velocity of sound. Principle. Yes, ma'am. So can you come out here? This is, it belongs to biocerebral. Don't by mistake I don't. Okay. So this will come out to us. This will just come to us. So, okay. Right. Velocity.
So the 10 log will be constant.
Yeah.
Intensity only improve.
So velocity of sound. Already we have discussed that sound can travel in different media, in the solid medium or liquid medium or gaseous medium. Especially we have discussed that velocity of sound in a string. Velocity of sound in a string is V is equal to square root of T by mu, where T is tension in the string and mu is linear mass density, means mass per unit length. T is tension in the string and mu is equal to linear mass density. Linear mass density can also call it as mu is equal to mass per unit length. Mass per unit length. Mass per unit length. In terms of different parameters also can express already I have discussed this in terms of density, this in terms of Young's modulus and in terms of temperature difference, etc. etc. So but if you want to express in terms of elastic behavior, elastic property means Young's modulus, you can say V is equal to square root of what do you call Young's modulus by rho. Young's modulus by rho. So here Y is Young's modulus and rho is density. Rho is density. This is in case of a string instead of the medium. Whereas the sound wave and one more point you have to remember here is that when the sound is travels, so that is if you take a string, the string of a guitar or any musical instrument, if you pluck it, the sound produces. The sound waves will produce. The sound waves will travel as a transverse waves in the strings. Same sound waves, if you just say, for example, I'm talking now, you are able to guys are able to hear. So by sitting in front of me or in the class in front of me, so the sound waves in the air medium travel like a longitudinal waves. I hope you remember what a longitudinal waves and transverse waves means. Transverse waves means. The transverse waves travel in the form of crests and troughs. Transverse waves travel in the form of crests and troughs. Crests and troughs. This is trough, crest, trough. Whereas longitudinal waves travel in the form of like these are compressions, then rarefactions, then compressions, rarefactions, then compressions, like rarefactions. This. So this compression, rarefaction, compression, rarefaction, compression, rarefactions. So here in both the waves, so in a solid medium like a string, sound travels as a transverse wave. In string, sound travels as a transverse wave, whereas in air medium, sound travels as longitudinal wave. Not only air medium, in liquid medium also sound travels as a longitudinal wave. Means compression symptoms in the form of compressions and refractions. We have to remember that distance between two successive crusts or troughs here and two compressions and rarefactions here will be called as lambda, the wavelength. Lambda, wavelength. And with the help of all this, you can say when we are dealing with the string, velocity of sound is given by in terms of elastic property root y by rho. Y is Young's modulus of the Young's modulus and rho is density of the medium. Whereas in air medium or in a fluid medium, liquid or gaseous medium, velocity will be given as the elastic property in those media will be nothing but because they are three-dimensional objects. The corresponding elastic property will be called bulk modulus of elasticity. So it will be denoted by B by rho, bulk modulus by rho density of the medium, right? This in general, in in general, where B is what? Bulk modulus, and rho is equal to density density of medium. Medium. So if we consider air medium, density of air equilibrium, that of liquid medium.
So next question. Is equal to I by J into DC.
Straight line of length by Newton carry current. Direct one. Direct formula
Yes,
is
sir. S is equal to I by A into DC.
I by A. And I by
Q will be B on velocity
A.
I
F is
square.
equal to what you are asking about force acting on the wire, current carrying conductor, not on moving charge. Moving charge means F is equal to QVB, charge of the particle, velocity of the particle, magnetic field into current carrying conductor means instead of Q will take I and length of effective length L into ILB.
IL.
ILB. ILB. Here I is current. Current is given. What is that? 1.2 ampere. Effective length of the wire, the straight wire, zero point 0.5 meter. B is also given to this. Right. Okay. Excuse me. Let us go ahead now. So, to understand this, actually, it is observed that bulk modulus will be different in different media. In actually, so liquid medium it will be different, and what you call gaseous medium it will be gaseous medium it will be different, and gases also different gases will be different. So, it is observed that bulk modulus, according to Newton, Newton has proposed a relation. We call it as Newton's formula. Newton's Newton's formula for velocity of sound in air medium is to understand this. Even though we will use this, V is equal to root B by rho, but bulk modulus is replaced with a different parameter called pressure. How is this is equation 1. We know in general you have to remember that bulk modulus is nothing but bulk stress by bulk strain. We know that bulk modulus B is equal to bulk modulus, which is equal to bulk stress by bulk strain. Bulk stress can also be called as volume stress. Bulk strain is also called volume strain. Volume strain is change in volume by original volume. It's called volume strain or bulk strain. Bulk stress, whatever stress, it is usually force by area. Force by area. But this force by area can also be called as pressure. So you can take it as P by delta V by V. But if you apply pressure and force on normally on outside, the volume will decreases. The decrease in volume is represented as minus delta V by V. So you can express as minus PV by delta V or dV also can express. So bulk modulus B is equal to minus PV by delta V. Let us see this is equation 2. Which one? You know, you can come after this. We are live now. Can you come after this? Yes. 5 minutes. Yes. See, see here B is equal to minus PV by delta V. PV by delta V. So this is bulk modulus. But you can say bulk modulus is yeah. So here what Newton's formula. Newton's formula, what he has proposed. Usually bulk modulus is P into V by delta V if it is volume is equation modulus. But what Newton has proposed is Newton proposed that sound waves travel through air medium under isothermal conditions. Newton considers, I can say, or proposed, consider propagation of propagation of sound in air under isothermal conditions. Under isothermal, we can underline this isothermal conditions. Isothermal means under constant temperature conditions. So to understand what is a bulk modulus in such case, isothermal equation is will be considered gas equation. Gas equation in general is given by in air medium. Gas equation is nothing but PV is equal to nRT, equal as ideal gas equation or gas equation. Right? If temperature is constant, any number of moles or is universal gas constant. If T is also constant, this entire right hand side will become right hand side part will become constant. So you can say this is constant. Then when sound waves are traveling, pressure will changes. Accordingly, volume of that region also will changes. The change can be expressed as by taking partial differentiation P into dV or delta V anyway you can take plus V into dP is equal to constant differentiation will be 0. So this you can write it as P dV is equal to minus P into dP. V into dP. Here, when you say actually here even while expressing here, you can understand just how to rewrite this one. You can say this P can be expressed as minus V into dP by dV. So, but if you observe this equation 2, P into V by dV, right? Minus, but actually this pressure P is not much change in pressure. I consider directly P only. Instead of this, that bulk stress, when you are applying, if you are applying change in pressure, volume changes. This change in pressure can be taken as a delta P, and then this will be delta P, and then this gives the change. This also will be delta P. So this you can take it as, if you say this is equation number 3, by comparing these two, you can say that this is bulk modulus minus delta P into V by delta V minus what is that? Delta dP delta P both are same into V by delta V is bulk modulus. This is not but bulk modulus. So I can replace this by from 3 and 2 and 3. 2 and 3 implies bulk modulus is nothing but pressure. So in equation 1, if you replace the bulk modulus with pressure, then you will get equation 1 gives velocity of sound waves in a medium is given by square root of v by rho becomes root of P by rho, where P is nothing but pressure of the air medium. That is also called atmospheric pressure. Pressure of air medium, atmospheric pressure. Rho is density of air medium. So density of air, pressure of air or pressure of atmosphere. We also call it pressure of atmosphere, atmospheric pressure. So pressure of air is equal to atmospheric pressure. Usually this value is nothing but 1.01 or 0.13 into the power 5 Pascal. And the density of air is considered to be 1.29 kg per meter cube.
He did not write 3 into 1.
Oh, no, no, 1.01 or 0.13, whatever it is. Okay, this is exact value on this numbers. So into 10 to the power 5 Pascal or Newton per meter square. So we substitute these values here. Okay, according to Newton, velocity of sound in air medium becomes approximately 280 meter per second. But this is not in good agreement with experimental value. But this is not in good agreement with experimental value. Experimental experimental value. So experimental value of the experimental it is standard speed of sound in air is given by experimentally it is given by around 332 meter per second. So but it is so much of difference is there. To overcome that Actually, different scientists have tried. One of the scientists called Laplace has given a correction to the Newton's formula. So this is called as Laplace correction. Laplace correction is also called as Newton-Laplace relation. You can also call it as Newton-Laplace formula or Newton-Laplace correction. Newton-Laplace equation. Newton-Laplace formula for what? Laplace correction, Newton-Laplace formula for speed of sound in air medium. So how this is derived is by considering a simple condition that Laplace has considered Laplace from adiabatic conditions. Consider sound travel in air medium under adiabatic conditions. Under adiabatic conditions. Adiabatic conditions. Adiabatic conditions means there will be no absorption of heat and rejection of or release of heat will take place. Quickly the what do you call the process will take place. The transmission of energy will take place and compression of air pressure will take place. That is the change in heat energy will be zero. It will not be absorbed or it will not be liberated. So this kind of process, under this kind of process, he has assumed and proposed that sound will travel. So according to him, to prove get the expression for to calculate the velocity of sound, we have used a relation of a gas equation under adiabatic condition. So adiabatic gas equation is given by adiabatic equation or gas equation. Adiabatic gas equation means you can say gas equation under adiabatic process. In thermodynamics, you might have studied about gas equations in different processes, isothermal process, adiabatic process, isochoric process, isobaric process, so on. So you can say adiabatic gas equation or gas equation in adiabatic process is given by PV power gamma is equal to constant, where gamma is adiabatic constant, where gamma is adiabatic constant. Actually, it is given by Cp by Cv and its value will be different for different gases, monatomic gas, diatomic gas, etc. Right? Now, so to understand under this condition, the change in pressure with respect to the volume is as PV power gamma is equal to constant, we can say P into the change in V with respect to change in V, a partial differentiation can perform. You can if you differentiate this V power gamma, you get gamma into V power gamma minus 1 dV or delta V plus V power gamma into dP is equal to change in constant is 0. And they simplify this, you can write P into gamma or gamma P, right? Gamma P into V power gamma minus V power gamma into dP. Here, this you can write as V power gamma into V power minus 1. V power gamma gets cancelled, right? So this can also be expressed as gamma P into V power gamma into V power minus 1 or V into dV is equal to minus V power gamma into dP. V power gamma gets cancelled. Now we can write here this sending this terms here, you can write gamma P is equal to minus dP into V or V into dP by dV. Let us consider this is equation number 4. Already have given some three equations, right? Yes? Yeah. So equation 4. Compare equation 2 and 4. 2 and 4. 2 and 4, actually dp into v by dv is nothing but bulk modulus. So we'll get gamma into p is equal to bulk modulus. Bulk modulus is equal to gamma into p. Now in equation 1, if you replace this, we'll get velocity of sound in a medium is equal to square root of bulk modulus by rho is equal to gamma p by rho, where rho is density of air and it is atmospheric pressure. The gamma is adiabatic constant. Now this can also be expressed as root gamma into root of p by rho. This already I have calculated by using Newton's formula. This is approximately by 280. So the gamma value is approximately for air it is around the value of gamma 1.4. So you can take it as a square root of 1.4 into 280 will give you approximately v is approximately equal to how much? What is root of 1.4? 1.4 square root is 1.18 into 280. 280 is equal to 331.3 or approximately 330 or 331 meter per second. But experimental value of speed of sound in air medium is 332 or around 330. So now this is absolutely in very good agreement with experimental value. So the velocity of sound in air medium with Laplace correction is in very good agreement with experimental value. Means this it can follow. That means it is a good condition. So you can follow this correction. That's why it is the scientific community has accepted this correction, and then thereafter the speed of sound waves in air medium will be calculated by using this relation. So, but the latest formula is a disregarded, defective nuclear. So you can say that velocity of Newton's formula, velocity of sound in air medium means gamma p by rho will take because it is undergo adiabatic process. Okay, under it travels under adiabatic process. So you can say velocity of sound in air is v is equal to square root of gamma p by rho. But this is called as Laplace formula. Laplace formula and under adiabatic condition. But Newton's formula says V is equal to discrete P by rho under isothermal conditions. But this is a well accepted relation. So this is briefly about what you call velocity of sound waves in air medium. But here you can write some additional points as V is equal to root gamma P by rho, where rho is density. If you write as density is equal to mass by volume, if you substitute here, I can write square root of gamma T by density is mass by volume. Volume if sent here it becomes PV. From gas equation, PV is equal to, because PV is equal to nRT. You replace this here. P into V is nRT. You can also rewrite this as gamma nRT by m under root. Here n is number of moles and m is mass of the gas. If you, n by m can be replaced with the molar mass or molecular weight. So if you want to express in terms of molecular weight, you write it as gamma RT by capital M, where capital M is equal to n by small m. Right? So this way also can express with under root. So these are different ways of expressing or calculating the velocity of sound in air medium in terms of
molecular mass is mass by moles.
num- actually if molar number of if you say uh, total number of moles is molecular. One molecule is having weight of this number of molecules. Here you can say um, weight of one molecule is m. If number of moles are n, and total mass is m. Total mass is m, right? Yeah. So we can write n by m. Yes. Actually, just you can say n by m is 1 by m. Yeah. So actually, this is n by m, n by small m is equal to 1 by capital M. 1 by capital M. So what you can hear, what you are expressing here. Uh, so n by m is molecular mass. This is the same way this you can get it right. Correct only. You can get correct only. So this way you can calculate speed of sound in the area by knowing the mass of the gas, number of moles, or molecular weight, or even temperature. If all these are constant, then we can say that speed of sound in air medium is observed to be directly proportional to the square root of absolute temperature. But absolute temperature is nothing but temperature in Celsius scale plus 273. Right? So at a particular temperature T, if you say velocity of sound is Vt, is directly proportional to, let's say, T plus 273 under root, right? And V at 0 degree Celsius is nothing but the square root of 0 plus 273 is 273. Then, in terms of this, you can also calculate the velocity of sound at a particular temperature as Vt by V naught is equal to square root of you can say 273 plus t by 273. On simplifying this, you can write it as 273 by 273 plus t by 273. It gives 1 plus t by 273 under root. That root can be expressed as power half. Here, by using binomial approximation, by binomial approximation, we can say 1 plus x power n is approximately equal to 1 plus n into x. Here in place of n we have half. This can be expressed as 1 plus half into t by 273. 273 into 2 will become 546. So this therefore can write Vt by V naught equal to this, or the velocity of sound and air at a temperature T is equal to V naught into at 0 degrees Celsius into 1 plus T by 546. Got it? In meter per second or in seconds. So this is how we can calculate the velocity of sound as a function of temperature. So it's the speed of sound or velocity of sound changes with temperature, and the variation we can understand with the help of this equation. Alright, this is briefly about how what is speed of sound in air medium and by under Rajathamil conditions and Radivadi conditions, which is the proper way of, which is the correct one to use, right? And how it depends on temperature, etc. Briefly, okay. And the numericals, just you can go through those numericals as well, which I have worked on. Alright.
Thanks.